Hello everyone, this is Shiva Prasad. Welcome to the course of C programming. Today let's explore the topic of algorithm. Algorithm plays an important role in computing world, and now algorithm is all about a set of instruction or a step-by-step instruction to accomplish any task or to solve any problem. And thereby we need to customize the inputs, and thereby we apply logic towards that to accomplish a perfect task to ensure a perfect output. And to represent an algorithm we follow different that is ideas like a flowchart, pseudocode and computer program. And now in a nutshell, let me tell you that the algorithm is all about a step-by-step solution to solve any problem, and flowchart is all about the diagrammatical way of representing an algorithm, and pseudocode is like an human readable code. It's also a customizable one, machine readable sometimes, and C program is all about the actual executable code. And thereby we need to create an algorithm by means of flowchart or by means of pseudocode and C programming as well. Now let's implement algorithm by means of a flowchart, which can be implemented using one of the tool called Raptor software tool. So Raptor is all about rapid algorithmic programming tool for ordered reasoning, and this is a tool that runs in Windows as well as Apple Mac. And now Raptor is a visual programming tool that uses flowchart. This helps us to implement algorithm in a graphical and diagrammatical way, and this uses symbols like inputs, output, process, decision and loop for all this means of that is implementation. So this software tool gives us a provision with respect to symbols, and thereby we can develop flowchart to implement an algorithm or any task. And this software in turn generate code in languages like C, C++, Java. So this software tool will be making use of symbols to implement algorithm by means of flowchart. And now let's explore different symbols we make use to develop a flowchart. That is starting from oval shape representation that we used to call it a start and end. This is meant for start and end purpose, and arrow mark is to interconnect all the symbols. And for input and output we use the symbol parallelogram, and for process or logic implementation we use a rectangle, and for decision making we use a rhombus. So with this help of all the symbols, we will be working on the Raptor software tool. And now coming to the GUI of Raptor tool. So this is the user interface appearance, and here you will find different options like starting from the menu bar and toolbars, all the symbol palettes, and the main workspace area where we will be working over here. And in the left side we will be having the symbol palette area, so where we will find all the symbols which can be used to create or design a flowchart. And thereby we have a watch window. This is mere equal to output window where we can instantly watch how the implement is all about. And other than that we have a sliding bar over here. This will ensure the speed of execution of our logic, and thereby nearby we have scaling factor that is used for the appearance of the workspace area. To zoom or to zoom in or out, we can make use of the different percentage. And now let's move on within the software. So before that, in the symbol palette area, I'll highlight you one of the important symbols. So we start from assignment. So this is meant for logical implementation purpose, or the process block we used to call that as, and followed by a call. This is meant for a function calling, and this can be used in a special rare cases, and mostly we'll be applying on input and output symbols. So input, the left side projection will be the input, and the right side projection will be the output, and thereby we will be getting into the selection or decision making. So this is called as selection or decision making. And finally we go with the looping concept. So these are all the main symbols we will be using in the flowchart design. And now we'll kickstart with the very first program of hello world program. and how to fetch out any means of any user defined command comment or any means of statement, how that appears. So here we will be making use of the symbol called output symbol. So we'll parallelly work with the software. So here we got into the workspace area, and now I'll be selecting output symbol, and I'll click over here and just drop over here. So initially we need to save that. So let this be program number 1, or flowchart programming 1. So once the symbol appears over here, we need to double click that, and since this is an output symbol, this is supposed to display the output or the comment what the user enters. And since the comments are character based and string based, we supposed to go with double quotes as stated in the previous example. And we will be following like hi, hello everyone, so or as an allowable program. And so once you click a done over here, so that appears over here, and when you execute now, so make sure the slider is somewhat in high speed, or in the beginning level you can make it in the 60%, and just now I'm making with the 80%, and scaling factor of any means of for our convenience. And now over here in the symbol palette area, you will have a run, that is, if you move the cursor near to that, you will find execute to completion. So once you run that, so the output appears to be as hi hello everyone. And this is the very first basic program one supposed to deal with this software tool, and thereby we'll move on to the further execution. Let me close this one. Now let me go with another program with respect to addition of two numbers. So here we will be making use of two inputs, say for under any variable, we so called A and B, and so with this variables we will get two different values from the user, and thereby we will get into the logical or rectangular box. Within that, we will call two variables. We will declare that two variables A plus B assigned to another variable called sum. So here we will be making use of a third variable called sum, and so with that the logic gets implemented based on A plus B arithmetic operation. So the numbers what you provide in the runtime, so that will be computed and calculated, and that will be get stored in the sum. So now to fetch out the output, so you will call this output the statement alongside with that variable you will call, such that you will get the output. We'll see in the software tool. Now we'll switch out to a new one. You can save or no, whatever maybe. And as usual, the workspace area you will find the start and end by default. And now since the addition of two numbers requires two inputs, you will click over the inputs, you will place it over here and again place it over here. I will reduce the scaling factor to some means for the user for the visibility convenience. And now we'll be getting into the assignment block, where you will declare your logic, arithmetic logic, and finally you go with the output. So we have chosen two input blocks, a process block and the output block, and to provide data within the input block. So once you double click that, you will find the first box called as enter prompt here. So you're supposed to enter any mere statement. So let that be within the double quotes. So first value, enter your first value whatever may be, and I'm declaring a variable called a. I'm getting it as done. So the a variable appears, and similarly second value will assign to the variable b, and input part gets over. Now we are assigning the third variable. So here we declare as C, and the logic is all about you add two variables, that is A plus B. So arithmetic operators will be calling over here. So this is case sensitive. We have to make use of the appropriate variable what we used over here. Here we have used a small a and small b, and such that we have to use it accordingly. And C and A plus B. So the set is all about the new, that is the output variable, and A plus B is all about the input variable. So we have assigned A plus B to C. So it is declared as, and C is assigned with A plus B. And now the output part, as usual, it should be within the double quotes. So you have to close this double quotes to fetch out your output, such that here finally to fetch the calculated output, you have to provide, you have to close with double quotes, and you have to make use of the plus symbol, and then you have to call the variable C. In C we have that is assigned with A plus B calculated thing, and such that your output is supposed to appear. And now things are done. So it is asking the very first while I'm running the program, and the first value is 5, okay, and the second value is 7. So the output calculated, the calculated output is all about 12. So even you can find that in the watch window, parallelly you can find in the master console window. So output 12 appears. So by the way, you can make use of the IO function, that is input, that is symbols, and assign to an assignment, that is a processing block, and the final output. So make sure that for any program we should have a dedicated input, and followed by the logical or process block, and thereby we end the complete program by using the output symbol. And let me once again scale to the next first, second, and C as into A plus B. Fine. So let me go with the next execution, that is decision making is an important area where if some scenario or situation comes, you need to decide whether which value is greater or smaller. Maybe I've taken the example of either A or B. So once the decision box, within the decision box, based on the comparison, so you make use of the relational operator, so to relate A and B on what perspective. So the example what I've chosen is A greater than B. So if it is greater, it should go with this output, displaying this output. If not, it has to display this output. And this is the exact logical implementation for comparing or the greatest among two numbers. And let me implement that in the Raptor tool. I'll go with I'll implement over here itself. I'm deleting this. You can make use of a keyboard delete command, and here thereby we already got first value and second value over here. And now we will be making use of the decision block or selection block we used to call from the symbol palette area. So now the symbol that is diamond shaped symbol appears, that is nothing but the decision making or selection block. So once you double click that one, so you will be asked to enter your logic. So here we have made use of two variables A, and I'm comparing with B. So I'm making use of greater than symbol with B. So A greater than B is the logic. So I made it done. If that is the case, you have to display an output such that it should so here selecting output, just click over here, again select that, click over here, and within the first output, so display that this as A is greater, and over here also B is greater. Done. So upon execution, so you can find yes, if I enter that as A value is 5, B value is 7. Yes, obviously that is the output of B is greater appears. So following the previous one, previous output, so we will be getting that as another new output, that is b is greater, so you can verify accordingly. And now we'll go with the third one, that is the next symbol is all about selection and the looping block, and the loop is all about the iterative block. So some activity should happen within the looping block, so it should have some starting value and it should have some stopping value, and thereby when you explore the symbol, so once you call the loop, okay, so here you have a loop, it is a closed circle fashion, so you will find the decision box over here. So whatever the logic you provide over here, based on that the loop starts and it terminates if the condition is not satisfied. So within the loop you will find the decision box that has to be properly noticed. And here the example what I've taken is counter program. So here to count the numbers from 1 to 10 for any means of applications concerned, so to just count the values, usually the counter starts from a value and that ends with some user expected value. So once you set the start value and the end value, the loop supposed to run within the start and end, right? And based on that, the example what I've taken is counting from 1 to 10. The example I've chosen over here. So here we have to first you have to initialize, declare the counter variable with 1. So that is a starting value, and when the 1 enters the loop, and here I have made use of the output to be displayed instantly, so the counter appears to be 1 as of the very first level is concerned. And when it enters to over here, the counter goes with the 1 is equal to, it is checking the condition that is equal to 10 or not. If it is not equal, it goes, and again the counter gets incremented to the previous, whether it's 1 plus 1 2, and again the loop goes on. Again 2 comes over here, 2 is equal to 10, it goes on, and again 3 goes over here, and 4 5 accordingly. So when the 10 appears, 10 is equal to 10, when the condition is equals, so the loop comes out of that and the loop gets terminated. And that is how loop is all about a iterative that is scenario. Let's implement in software. Okay, so as the counter is concerned, so we have to deal with making use of the looping concept. So for that I have made use of the loop first of all. So once the loop is clicked and dropped, so loop has got a decision box over here. Now we need to implement a counter logic, right? And here we have to start with initializing the counter with 1 as stated in the presentation. So here I make use of the assignment symbol. So assignment, so here once I double click, and the counter, so we used to declare the variable counter, that is value set to 1. So counter starts, supposed to start from 1, it enters the loop, and you provide a condition over here, right? So here you go with a condition like counter is equal to 10. That is the case, it should perform some action. So the count is set to 10, and now here again I'm making use of the assignment symbol. So here counter is made with counter data, current counter data plus 1. So the current counter data is all about 1, so 1 plus 1 is 1. So based on the condition, it keeps on incrementing. So the first value enters the loop, checks the condition, 1 is equal to 10, no. So the counter gets incremented from 1 plus 1 is 2, so 2 gets over here and enters the loop, and the 2 is equal to 10, no. Again 2 plus 1 is 3, and it goes on, the loop goes on in an iterative fashion. So once when it reaches 10, so 10 is equal to 10, if the condition is yes, it will come out of the loop. And here to track instantly, it's optional that you can make use of the output over here such that the counter thing can be counter value can be noticed. Okay, so we have declared a counter with 1 and it enters the loop. Instantly it will display the counter value and checks the condition. Again it's incremented based on counter plus 1 value, and the iteration goes on up to the 10 is equal to 10 reaching. reaching point. Now let me execute. Yes, counter running for 10 times. When it reaches 10, it will come out of the loop, such that we are getting the output as from 1 to 10. So the loop is used to perform an iterative action with respect to a starting value and the condition based the terminated value, such that the loop runs within the closed loop fashion. I hope that you people have got some idea with respect to the Raptor tool usage to implement a flow chart, to implement an algorithm using a flow chart approach, and thereby we perform all the logical implementation using a symbols with respect to the flow chart is concerned. So once the flow chart is made, you can even generate to respect to C code also. That can be an optional one. You can generate different codes and you can run in the different platforms. So this tool will enable us to ensure ourselves with a visual representation of the algorithm, such that we can go with the program implementation very comfortable and easily. Anyhow, let me sign off with today's session, and I hope that all the things have been properly covered. Thank you all.